Hello students, welcome to another session of this differential equations. In this session, we will be discussing particular solution of differential equations by the method of separation of variables. So let's have an example. Find a particular solution of the differential equation satisfying the condition. So you will be given one differential equation and you will be asked to solve or find the particular solution. So I will be taking example from the exercise 9.4. So here is the example. Dy by dx is equals to, it is y tan x. You are given dy by dx is equals to y tan x and you are given some initial conditions. You are given the value of y is equal to 1 when x is equals to 0. Okay, so using this condition, y is equal to 1 when x is 0. So you have to find particular solution. So particular solution andre it is obtained from general solution by substituting particular value of the constant. First you need to find the general solution. Okay, so first we'll find the general solution and then we use the conditions this. Okay. So dy by dx is equals to given y tan x. Now we have to solve this by separation of variables. As the variables get separated easily, bring y this side. So dy by y is equal to, it is tan x into dx. Okay, bring this dx this side. This is equals to integrating both sides. Once the variable gets separated, you have to integrate. Integration of tan x dx. Okay, so integrating. So you must be good at integration, then only you could able to solve every differential equation. Now integration of 1 by y, that we all know, log y. Integration of tan x is a log sec x. That must be known. And if all the terms are in terms of log, better you keep constant also in terms of log. Okay, logs is also constant. This log y is equal to log m plus log n is log mn. So I can write log of sec x into c. So I can write c constant first into sec x. Okay, log m plus log n is log mn. So both side log, you may take anti-log, that we call removing log. So you can write y is equal to c secant x. Okay, so this is the general solution. Okay, so this is the general solution. So solution involving the constant. This is the general solution. Now you need to find particular solution. Particular solution means by using initial values, whatever you are given values, using that y is given and x is given. If you put here, you will get the value of c. Now, you are given y is equal to, you are given y is equal to 1 when x is 0. Okay, so you have to put these in this. Therefore, 1 becomes substitute. So if you substitute y is 1 here, 1 is equal to x c into sec 0. Okay. As we all know, sec 0 is 1 because cos 0 is also 1. The value of sec 0 is 1. So this gives you the value of c. So gives c is 1. Now you have to substitute this in 1 In this equation you will get particular solution. Therefore, put this in 1. So we have y is equal to c into sec x. So c is 1. So that gives you secant x. So this is the particular solution. This is the particular solution. So in this way you have to find the particular solution by finding the value of the arbitrary constants using given conditions. Let's have another example. Find the particular solution satisfying the given condition for given differential equation. So you are given x into x square minus 1 or dy by dx equals to 1, and the conditions are y is equal to 0 when x is 2. Okay, we are also called, these are initial value problems also. Okay. Now first you need to think of the method. Here the variable separable method we use because there is only x terms in the product, so you can very easily bring this. So I call it as separating variables. I can write directly it as dy is equal to, you can transfer this term and dx in the numerator, separating variables. Separating variables. Separating variables. Now once the variable gets separated, integrate. Integrating on both sides, integration of dy is equal to integration of 1 by x into x square minus 1 dx. This implies integration of dy is y, and here you think of the method. Okay, so I can write x square minus 1 as x plus 1 into x minus 1, and as you know how you can integrate this by partial fraction. So I will be doing in detail, so by practice you can do it in short time. Okay, by partial fraction, by partial fraction, 1 by x into x plus 1 into x minus 1 can be written as a by x, b by x plus 1, c by x minus 1. Okay. This implies if you multiply this side, multiply by x into x plus 1 into x minus 1, multiply by x into x plus 1 into x minus 1. So what will get? This side you will left with 1. Here you will get a into, if you multiply x cancels, so you left with 1 x plus 1 and x minus 1, along with b x into x minus 1, and with c x into x plus 1. Okay, if you multiply this term to the right, so denominator get cancels, you left with two terms. Now try to make one of the factor 0 by choosing suitable x. X and new choose ಮಾಡಿ ಒಂದ್ಸಲ ಇದನ್ನ 0 ಅಂತ ಚೂಸ್ ಮಾಡಿ, ಒಂದ್ಸಲ ಇದನ್ನ 0 ಅಂತ ಚೂಸ್ ಮಾಡಿ. Once you have to choose this as 0. Okay. So put x equal to 0 in this. Okay, I can call it as 2. So what will get? 1 is equal to a into, if you put 0 here, we left with 1 minus 1. Okay, and here we have x multiplied, so next two terms are zeros. Now from this, 1 into 1 minus 1, so that is minus a you will get. So which gives you a is equal to minus 1. So this is one value. Similarly, you have to choose another factor 0 and try to find the value of another constant. Okay. So now I will choose. Okay. So a is minus 1, remember? Right now. Now you have to put second one, case second, x plus 1 is equal to 0. That is, you have to choose this factor 0. That is, x is equal to minus 1 in equation 2. In this equation, you have to put. See here what will happen. 1 is equals to, if you put x plus 1 is equal to 0, so x plus 1 is 0. So first term becomes 0. B into, so you are putting x as minus 1. Second term remains, and this term becomes 0 because we have x plus 1 here. So this implies 1 is equal to b into minus 1 minus 2. So 1 equal to 2b. So b is 1 by 2 will get. B is 1 by 2. Okay. So a was what we had, a as minus 1, b as 1 by 2, and now you have to find c. Okay. Now we have another different factor x minus 1, so put that. Put x minus 1 is equal to 0, that is x is 1. So what will get? 1 equals to, if you put here, this term becomes 0 because we have x minus 1 here. Second term becomes 0 because we have x minus here, minus 1. C into 1 into 1 plus 1 you will get. So 1 is equal to 2c you will get. C is also 1 by 2. Okay. Now we got the values of a, b, c. So what we had, look here, this is your y. Okay, so y is means integration of this. So I can write, so therefore y is what we had this 1 by x into x plus 1 x minus 1 dx. This is equals to, we have written it as by partial fraction, a by x, b by x plus 1, c by x minus 1. Integration of 1 by x is log, so I can write a log x. B into integration of 1 by x plus 1 is log x plus 1. Integration of c by x minus 1 is, it is log or c log of x minus 1. And the constant, I can keep the constant of integration as k because already there are a, b, c are taken. So a is minus 1, so I can write minus log x. B is 1 by 2, so log of x plus 1. C is also 1 by 2, log of x minus 1 plus constant k. This is your y. Okay, further simplify it, take LCM as 1 by 2. So minus 2 log x plus log of x plus 1 plus log of x minus 1 by 2 plus constant k. Further, this minus 2 can be written as, or you can write minus as it is, 2 log x can be written as log of x square plus log of log m plus log n is log mn. So I can write log of x plus 1 into x minus 1 by 2 plus k, which is equals to, now log m minus log n is log m by n. So I can write 1 by 2 outside as it is. I can write it as log of x plus 1 into x minus 1 by x square plus k. So this is your general solution. So if you want, again you can write it as x plus 1 into x minus 1 as x square minus 1. So now you have to put, this is your equation 3. Now you have to put the given conditions, okay, to find the value of k. So you are given y equal to 0 when x is 2. You are given initial condition y equal to 0 when x equal to 2. So put this in this. So what will happen? Just see. Okay. So let me copy this first. So we substitute here. Let me rub this. Okay. Substitute y equal to 0. So 0 is equals to 1 by 2 log of x as 2, you have to substitute. It is 2 plus 1 and 2 minus 1. So 2 plus 1 is 3, 2 minus 1 is 1, divided by 2 square is 4, plus k. So this gives you 0 is equal to 1 by 2 log of 3 by 4 plus k. So k is minus 1 by 2 log of 3 by 4. So this you have to put in 3. Therefore, particular solution is, okay, here it is substitute. It is minus 1 by 2 log of 3 by 4. Okay, so in this we have to find the particular solution. Let's have one more example. Find the particular solution of the differential equation. You are given cos of dy by dx equals to a is a constant which is a real number, and you are given y is equal to 1 when x is 0. Okay, so using these conditions you have to find the particular solution. Okay, so given cos of dy by dx equals to a, I can write dy by dx is equals to cos inverse of a. Separate the variable, dy is equals to cos inverse of a into dx. Cos inverse a is now constant here. Integrating both side, integration of dy, this cos inverse a is a constant, I can keep outside the integral, into dx. So integration of, here it is dy. So integration of dy is y, cos inverse of a into integration of dx is x, plus constant c, constant of integration. So this is your general solution. This is the general solution. This is the general solution. Okay, now given, what are the given conditions? You are given y is 1 when x is 0. This means that this is the one curve. So it passes through the point 0, 1. That is the meaning of this. Okay, on solving any differential equation, whatever the solution you will get, that represents one curve. Okay, and you are given that this curve passes through the point 0 and 1. So this point satisfies this equation. So put here. So therefore 1 becomes, substitute here. So in place of y1 equals to cos inverse of a, x as 0 means this full term becomes 0, plus c. So you got the value of c as 1. Okay, so put this in equation 1. Therefore particular solution is y is equals to cos inverse of a into x plus constant c means 1. Okay, so we have substituted the value of c in this equation. In this equation we have substituted the value of c. So in this way you can find the particular solution. So there are few more standard examples. Let's see. Now see here is an interesting example. This is from exercise 9.4. This is 9.4 exercise and problem number 15. Find the equation of a curve passing through the point 0, 0 and whose differential equation is given as y dash is equal to e power x sin x. Okay. So given, you may write, given can be written as dy by dx is equals to e power x into sin x. Okay, now on solving this you will get one curve, and what is it is given that curve passes through the point 0, 0. Okay, so first you solve this, you will get the curve or the solution of this differential equation. So first separate the variables. Dy is equals to e power x into sin x dx. Okay, separating the variables. Once the variable gets separated, integrate. Okay. So this implies integration of dy is equal to integration of e power x into sin x dx. Okay, now you must know how to integrate this. That's direct way. Note down this. Integration of e power ax into sin bx. Those who knows this, they can do it. Otherwise, no, you can't. Integration of e power x into sin bx is, it is e power ax by a squared plus b squared into a sin bx minus b cos bx. Okay. So in this case, here a is how much? Here a is 1, coefficient of x in the power of e, and b is 1, coefficient of x here. So this implies integration of dy is y, and here you need to apply this formula. It is e power x divided by a square plus b square. 1 square plus 1 square is 1 plus 1, that is 2 you will get. A sin bx, a is 1, so just sin bx means sin x, minus b is also 1, you will get cos x, plus constant c. This is your general solution. This is your general solution. This is the general solution. Okay, now given, you are given initial conditions. Given the curve passes through the point 0, 0. Okay, so this is the curve of the given differential equation. Given that one passes through, the point 0, 0, that is x, 0, y, xy is 0, 0. So now put x equal to 0 and y equal to 0. So 1 becomes, if you put y equal to 0, 0, e power 0 is 1, so 1 by 2 will get, sin 0 is 0, cos 0 is 1, plus c. Okay, so e power 0 is 1, I am writing directly. So this gives you minus 1 by 2 plus c. So c is equal to 1 by 2 will get. Okay, now you have to substitute this in the general solution. Okay, so put this in 1, so you will get put this in 1, so y equals to e power x by 2, it is sin x minus cos x, and we had plus c there, so plus c means 1 by 2. So this is to be remembered. Let's have one more. Find the differential equation. This differential equation, for the differential equation xy dy by dx equal to x plus 2 y plus 2, find the solution curve passes through the point 1 minus 2. Okay, so you have to find general solution of this, and then you have to substitute these points and then find the value of constant and substitute in the general solution. Okay, right. So you are given this xy dy by dx equals to x plus 2 y plus 2. Those who knows the ways of or methods of solving differential equations, integrations, methods of evaluating integrations, those can only crack this. So first separate the variables. Separating variables. Y term, okay, I can bring y plus to this side into dy, x plus 2 divided by x here, and this dx in the numerator. Okay. Once the variable gets separated, integrate. Integrating. Integration of y by y plus 2 dy equals to integration of x plus 2 by x dx. Okay, think of the method. So what I do is, in the numerator, I can add and subtract 2 so as to make numerator as one of the term containing. So I can add and subtract 2 in the numerator. Here I can just separate them, x by x, 2 by x. Okay. So this idea will come only when you practice enough number of examples. Okay. So y plus 2 by y plus 2 minus 2 by y plus 2. I can write it like this. X by x is 1, integration of 1 plus 2 by x dx. Okay. This is y plus 2 by y plus 2 is 1 minus 2 by y plus 2 integration 1 plus 2 by x dx. Okay. Now integrate. Integration of 1 with respect to y is y. 2 into integration of 1 by y plus 2 is log of y plus 2. Here also integration of 1 with respect to x is x. It is 2 log x plus constant c. Okay. So if you want, you can write it in more general form. Y minus x equals to 2 log x plus 2 log of y plus 2 plus c. If you want, you can write y minus x is equal to, I can write as log of x square. Okay, 2 log x is log of x square, and this can be also written as log of y plus 2 whole square, and you will get log m plus log n. You can get log mn. Okay. So I can write it as, it is log of x square into y plus 2 whole square plus log m plus log n is log mn. Okay. Now you need to put the given condition. What it is given, that you are asked to find the solution curve which passes through the point 1 minus 1. This is the solution curve. This is the general solution or solution curve. This is the solution curve of the given differential equation. Now if it passes through the point, if it passes through the point 1 minus 1, means this point satisfies this equation. So this implies substitute y as 1, minus 1 and x as 1. So put y is equal to minus 1 and x is equal to 1 in equation 1. So what you will get? You will get minus 1 log of x square, that is 1 square, and y minus 1 plus 2 whole square plus c. So you will get minus 2 and you will get log 1 here. So log 1 is 0. So you will get c is equal to minus 2 because log of 1 is always 0. So now you have to substitute in this solution curve. So put this in 1, you will get y minus x is equals to log of x square into y plus 2 whole square minus 2. Okay. So this is the required curve that passes through the given point. You can verify. If you put corresponding x, you will get corresponding y. Let's have 2 more on this and we'll end up the session. Okay. This is example number 17. Find the equation of the curve passes through the point 0, minus 2, given that at any point x comma y on the curve, the product of the slope of its tangent and y coordinate of the point is equal to the x coordinate of the point. Okay. Understand, you need to find the equation of the curve passing through the point 0, minus 2. You are given that, look at this, given that at any point x comma y on the curve, the product of the slope means immediately slope of the tangent. Okay, so slope of the tangent is denoted by dy by dx. Okay, so you are given that the product of the slope of its tangent and y coordinate of the point is equal to x coordinate. Suppose this is the curve here and this is a tangent drawn at the point x comma y. Slope of this tangent is dy by dx. Remember this. And you are given that the product of the slope of the tangent and y coordinate of the point is equal to x coordinate of the point. So that's a funda. So what is given? The product of slope of product tangent, slope and y coordinate of the point, that is y is equal to x coordinate of the point. X coordinate of the point is x. So this is your given. So this is can be written as dy by dx into y is equal to x. Very simple. You got the very simple differential equation. So y dy is equal to x dx. So integrate. So integration of y dy equal to integration of x dx. One can write directly. Integration of y is y square by 2. Integration of x is x square by 2 plus c. This is the solution, general solution curve. And you are given that it has to pass through the point 0, minus 2. Look at this. You need to find the equation of the curve that passes through the point 0, minus 2. Okay, so this is a general curve which passes through some point. Now you need to find particular curve. Okay, so if it passes through the point 0, -2, okay, so what is the value of C then? So this implies substitute x as 0 and y as -2 here. So if you put -2, you will get 4 there. If you put 0 here, 0. So this gives you C is equal to 2. Okay. Now you substitute here. So you'll get required curve. So required curve is y square by 2 is equals to x square by 2 plus 2. The value of C is 2. Or you can write, if you multiply by 2, y square is equal to x square plus 4 you will get. Okay, so this is the required curve which passes through the point 0 minus for the given condition. Okay, we will have last of this session. At any point x comma y of a curve, okay, so this is the curve, and at any point x comma y, the slope of the tangent is, so this is your tangent drawn at this point. Its slope is denoted by dy by dx. This is its slope. What it is given that the slope of the tangent is twice the slope of the line segment joining the point of contact to the point -4 -3. Okay, so there is, imagine that there is one more line, say, which passes through the point -4 -3. Okay, and its slope is given, slope of the line joining line segment, slope of the line segment joining the point of contact to the point this. Okay, so what is given as slope of the line segment, slope of the tangent is twice the slope of this. So what is slope of this line you have to find? Slope of the line joining this point and the point of contact. As you know, its slope is given by slope of the line segment joining 2 points, y2 minus y1 by x2 minus x1. Okay, so what it is given is, therefore, by given slope of the tangent is equal to, what it is given, twice the slope of the line segment joining, it is 2 times slope of the line segment joining the point of contact and the given point. So I can write y2 minus y1 by x2 minus x1. So slope of the tangent is given by dy by dx, 2 into y2 I take y minus y1 is your given point, that is -3. x2 is x I take, and x1 is given to be -4, that is -4. Okay, look at this. I have taken this as x2 y2 and this as x1 y1. Okay. This is dy by dx equals to 2 into y plus 3 by x plus 4. Okay, now we need to solve this differential equation. So separate the variables. Dy by y plus 3 is equals to 2 into dx by x plus 4. Dx I transferred this side. This is called separating variables. Integrate. Once the variable gets separated, integrate. Let's see, while integration of 1 by y plus 3 is log y plus 3. 2 into integration of 1 by x plus 4 is log x plus 4. And if all the terms are in terms of log, you can keep constant also in terms of log. Further, you can write log of y plus 3 is equal to, you can write it as log of x plus 4 whole square. And log m plus log n becomes, it's log m, and you can write c here. Okay, I reduced one step. So both side log, I can write it as y plus 3 is equals to x plus whole square into c. So this is the general solution or the curve for the given differential equation. Now it is given that it passes through that minus 1 comma minus 2 comma 1. It passes through minus 2 comma 1. So substitute y as 1 and x as minus. So this implies 1 plus 3 is equals to minus 2 plus 4 whole square into c. This gives you 4 is equal to 4 minus 2 is 2, 2 square is 4 into c you will get. So this implies c is equal to 1. Okay, substitute here. So you will get required curve. Therefore 1 becomes y plus 3 is equals to x plus 4 whole square. Okay, so this is all about exercise 9.4. I have done almost all important problems I have done. So go through these first and you can practice the remaining examples. So in the next class, we will be coming with another way of solving differential equations, that is solving homogeneous differential equation. So take care and keep watching. If you like, then press the like button and don't forget to share with your friends. So take care.